Welcome to The Explainer. Okay, we are diving right into a completely mind-boggling mystery today about a structural pillar of human civilization that, well, essentially faked its own death. We're talking about a piece of technology that powered virtually everything in the first half of the 20th century, got completely written off by the global electronics industry in the 1960s, and yet it's secretly running absolutely critical parts of our modern world today.
$3.3 billion. I mean, that's not pocket change, right? That is the staggering 2025 global market value of a technology the entire world agreed was utterly obsolete over 60 years ago. And it's actually projected to surge past $5 billion within the decade. The technology we're talking about here is the vacuum tube. And honestly, how it survived its own widely publicized funeral is one of the most fascinating engineering stories of our time.
The tech that refused death. To really wrap our heads around how this technology refused to die, we need to quickly look at its origins, its massive rise and fall, and how it retreated to the shadows.
It's honestly incredible how fast this technology reshaped the world. It starts back in a London physics lab in 1904 with John Ambrose Fleming's oscillation valve. But the real game changer? That happens just 2 years later, in 1906, when Lee de Forest adds a third electrode to create the Audion triode. That single, brilliant addition allowed engineers to amplify electrical signals for the very first time. It literally changed the trajectory of the 20th century. By 1940, we get the top-secret cavity magnetron, which enabled compact radar for World War II ships and aircraft. For decades, these glass and metal vacuum tubes were the single most important technology in all of electronics.
The rise and sudden fall. But, as engineers pushed harder into the computing era, the massive physical limitations of the vacuum tube were suddenly impossible to ignore.
The breaking point was just staring everyone in the face. Consider ENIAC, finished in 1946, as the world's first general-purpose electronic computer. This thing used 18,000 vacuum tubes, weighed 30 tons, and drew enough electricity to power a small neighborhood. But the real nightmare? It burned through a tube every day or two. The thermal stress meant it basically had to run continuously just to survive. Then along comes the ultimate solution, the transistor. It was solid state, meaning it was dramatically smaller, lighter, incredibly durable, and generated a fraction of the heat and power draw. For everyday applications, it was just a total no-brainer.
Now, the transition wasn't exactly overnight, but the writing was definitely on the wall. In 1947, Bell Labs demonstrates the first transistor. By 1954, you've got commercial transistor radios hitting the market. And by the 1960s, once engineers figured out how to pack millions of solid-state transistors onto a single silicon chip, the economics were undeniable. Major manufacturers across 3 continents, giants like RCA, General Electric, and Philips, they all shuttered their tube factories permanently. Decades of institutional knowledge just scattered to the wind. The consensus was absolutely final. The vacuum tube was dead.
Hiding in plain sight. But here's the twist. The real story is what was happening in the places nobody was watching, because vacuum tubes simply retreated it to highly critical, specialized domains.
So the crazy part is they didn't actually vanish. They just stopped interacting with everyday consumer electronics. Well, mostly. Did you know that the single most mass-produced vacuum tube in history is sitting in over 1 billion modern kitchens right now, literally hiding in plain sight? If you own a microwave oven, you own a vacuum tube. The cavity magnetron, the exact same type of tube that powered World War II radar, is generating microwaves at 2.45 gigahertz right now to heat up your leftovers. Sure, solid-state alternatives exist today, but for the price point of a consumer microwave, the vacuum tube is still basically unbeatable.
And way beyond the kitchen, vacuum tubes do what solid-state tech simply cannot match in high-power, high-stakes environments. They power military long-range naval radar, throwing out the massive radio frequency power needed to detect targets at extreme distances. They run our satellite communications. In hospitals, medical linear accelerators use vacuum tubes to generate microwave energy, producing the high-energy X-rays used to precisely target and destroy cancer tumors. And this is my absolute favorite. NASA's Voyager 1, the most distant human-made object in existence, is currently 15.8 billion miles from Earth. What's keeping it talking to us? A traveling wave vacuum tube amplifier that's been operating continuously in deep space for 49 years.
The search for perfect sound. Beyond those high-stakes scientific fields, this older technology also found a massive, fiercely loyal lifeline in the modern consumer audio market.
While the general public happily embraced the flawless efficiency of digital audio, audiophiles and musicians ran in the exact opposite direction. Why? Well, it all comes down to harmonic distortion. When you push a vacuum tube, it produces this specific harmonic profile that lab equipment can measure and that human ears perceive as warmer, richer, and just vastly more natural than solid-state amplification. It gives you that warm, dynamic overdrive that's the literal foundation of rock, blues, and jazz. Think about this. A massive 38% of the 2024 guitar head amplifier market belongs to tube amplifiers. That is huge. And this isn't just some nostalgia tax paid by aging hobbyists. These are working professionals actively dropping premium prices for this supposedly obsolete hardware. Major, legendary brands like Fender, Marshall, and Vox keep making them because musicians absolutely demand them over cheaper digital alternatives that just can't quite replicate that organic, living sound. A fragile supply chain. However, the mainstream tech world, completely forgetting about vacuum tubes, ended up creating a terrifyingly fragile global supply chain. Because the broader tech industry moved on, tube manufacturing got concentrated into a very small handful of countries, which created some really intense vulnerabilities. In March 2022, following the onset of the conflict in Ukraine, Russia imposed an export ban on over 200 categories of goods. Vacuum tubes were right there on the list. Overnight, a massive factory in Saratov, Russia, operated by Electro-Harmonics, just went dark. This one single facility produced tubes for 7 major global brands. It sent the entire global audio industry into sheer panic. Websites were pulled offline, and musicians were scrambling to stockpile whatever inventory was left on the shelves. That severe disruption forced the whole industry to wake up. It showed everyone that a single geopolitical event could sever the world's supply of a critical component overnight. And that is exactly why companies like Western Electric are now racing to revive domestic manufacturing. Originally the manufacturing arm of AT&T, Western Electric is bringing production of the 12AX7, which is the most widely used preamp tube in guitar amplifiers, back to American soil at a state-of-the-art factory in Georgia. They realize that securing the supply chain is quite literally the only way to protect the industry from going completely silent. The future is a vacuum. So the crucial takeaway we are arriving at here is that the vacuum tube isn't just some resilient relic clinging to life, it is actively being reborn for the future. Get this, NASA is brilliantly reinventing the whole concept. At NASA's Ames Research Center, engineers are actually developing nanoscale vacuum channel transistors. They're taking standard semiconductor manufacturing techniques, but instead of pushing electrons through solid material, they etch microscopic vacuum channels right into the chip itself. Why do that? Because electrons actually travel faster through a vacuum, and even more importantly, a vacuum can't be damaged by cosmic radiation. Conventional chips degrade or just die in deep space. Vacuum-based devices are inherently immune to it. It's this elegant fusion, taking the radiation immunity of 1900s vacuum tubes and mashing it up with 21st century semiconductor miniaturization. And that brings us right back to the financial reality of this ultimate technological survivor. Driven by aerospace defense, satellite comms, medical applications, and high-end audio, the jump from a $3.3 billion valuation in 2025 to a projected $5.3 billion by 2032 speaks volumes. The traveling wave tube segment all by itself is expanding rapidly thanks to defense and space investments. This market isn't just surviving, it is actively growing at a compound annual growth rate of around 7 to 8%. So, the obituary for the vacuum tube was clearly about 60 years premature. It's heating our food, it's treating cancer, protecting nations, exploring interstellar space, and creating the soundtrack of our lives. It really makes you realize that sometimes older technology isn't inferior, it's just highly specialized. Which should leave us all wondering, if the vacuum tube never actually died, what other forgotten, obsolete technologies are secretly holding our modern lives together right now? Thanks so much for joining me for this explainer, and keep questioning what you think you know about the tech all around you.